guys, today we're going to learn about classifying triangles. By the end of this lesson, you will be able to describe types of triangles based on side lengths and angle measures. Go ahead and get out your notes and be ready to learn. Let's get started. To begin, let's talk about angles of triangles. Triangles are named by the three angles. Angles can be named in two different ways. So let's look at triangle ABC over here to the right. We've got angle A here. That is where these two lines meet and make this vertex. But we can also call angle A something different by looking at the other points that make up that angle and naming them in that order. So looking here, we could start at this corner and have BAC. And we can also go backwards and look at C to A to B and name it that way. We can do the same thing with some of these other angles. So looking at angle B, that is right here, but we can name it by the 3 points that make up that angle, A, B, C, or C, B, A. Look at angle C here and determine on your own, what do you think the other ways that we can call this angle? So looking at this point here, we've got A, C, B, or we have B, C, A. The one important thing about naming angles is that you need to have the vertex in the middle of your name. So looking at angle A, we've got A in the middle. Looking at angle B, we have B in the middle. And looking at angle C, we have C in the middle. So you can have the two endpoints on either side, but that angle, the corner, has to be in the middle of your name. Next, we'll talk about some characteristics of angles in a triangle. The most important thing, or one of the most important things about a triangle, is that the sum of the three angles in a triangle is 180 degrees. So, using information about the triangle, we can set up an equation to determine any of the missing angle measures. Next, let's talk about side lengths of a triangle. The side length of a triangle corresponds with the angle measure opposite the side. And remember from the last time that opposite just means across from. For example, we've got triangle ABC over here to the right. I have side AB listed with the 2 points that make that side. Side AB corresponds with angle C because C is across from that side. Next, I have side BC. This corresponds with angle A because angle A is across from BC. Finally, looking at CA, can you tell me what angle corresponds with this side? Side angle B corresponds with side AC because angle B is across from that side. One thing that we know about side lengths of a triangle is that the smallest angle will be opposite the shortest side and the largest angle will be opposite the longest side. Using another vocabulary word we talked about in the last lesson, a side is congruent to another side if it has an equal length. Angles can be classified according to their side length and angle measures. Looking at side length classifications, we have equilateral, isosceles, and scalene triangles. First, let's talk about an equilateral triangle. You can draw a picture here. I inserted a picture of an equilateral triangle. An equilateral triangle is where all sides are equal. You can kind of remember this by looking at the word equilateral, and the first part of that word looks like equal, spelled just a little different. Picture the sides being equal are indicated with these dashes on each side. One thing to notice about an equilateral triangle is that the angles are also equal. Now, you've kind of just got to know the differences between equilateral, isosceles, and scalene. So I'm going to give you a couple different ways that I remember these. First, looking at equilateral, that starts with the letter E. And when you draw a capital letter E, you have these three lines that make up the letter E. So since it has these three lines, you can remember that all three sides are equal because we know triangles have three sides. So there's the one way that I remember equilateral. I'll tell you my other way of remembering the differences towards the end. Next, let's look at isosceles. In an isosceles triangle, two sides are equal as well as two angles. So you can see in this picture, these are indicated by these dashes on the sides and these angle measures. Using my strategy of remembering isosceles versus equilateral, if you draw a capital letter I, we have these two lines that are congruent or equal, and so I match that capital I with two equal pieces to isosceles with two equal pieces. Here we have a scalene triangle. Scalene triangles have no congruent sides and no congruent angles. So you can see those labeled here with the different dashes. Since all three dashes are different, here I've got one, here I've got two, here I've got three, and then same thing with the angles, this tells me that none of them are equal. Again, using my strategy of remembering here, if I draw a capital S, there's nothing that's the same here. It's a big old curve. So since that S is just a curve, that means none of the sides are equal. Now that we're towards the end of looking at equilateral, isosceles, and scalene, the other way that I can remember, these right now are in alphabetical order. E, I, and then S. With the names of the side length triangles in order from alphabetically, we've got them going down. So you can think about it like a countdown. 3, 2, and then none. So that tells me that the equilateral triangle has 3 congruent sides, isosceles has 2, and scalene has none. Next, we're going to look at angle measures. With angle measures, we've got acute, right, and obtuse. So first, looking at an acute triangle. An acute triangle is a triangle where all of the angle measures are acute, or less than 90. So in this example, we've got 75, 65, and 40. Those are all less than 90. Next, we have a right triangle. A right triangle is where one of the angles is a right angle or 90 degrees. In this diagram, that is right here, and right angles are indicated with this box in the corner. Then finally, we've got an obtuse triangle, and this is determined based from one side being an obtuse angle. I know this is kind of a small picture, but you can see that we have a 30-degree angle, 40-degree angle, and 110. And obtuse is being greater than 90 and less than 180, so here we've got that obtuse angle at 110. So to summarize, we can classify triangles based on side lengths. We have equilateral, isosceles, and scalene, and we can also classify triangles based on their angle measures, and there we would have acute, right, and obtuse. Make sure that you have these diagrams and these classifications written down on your notes, and I would maybe make some flashcards or something to help memorize the differences between these different classifications. Next, we're going to use these 4 images of triangles to answer some of the questions about their angle measures and side lengths. So in question 1A, it says, which side corresponds to angle MNO? So first, I need to find MNO. Remember that this middle letter is the vertex, or the corner. So MNO is this angle right here. So the side across from that, or opposite of that, is the one that's going to correspond. And so that would be side MO. Since it has 2 letters here for the side, that's how we're going to name it, MO. When you talk about sides, you put a line over the top of your letters to indicate that that is a side. Next, let's look at what side corresponds to angle TUS. So I need to find TUS, and that's in this triangle right here. Here's TUS. So I'm looking right here at this angle, and it wants to know what side corresponds to this angle. So the side opposite here is this side, and the letters that go with that side are T and S. Go ahead and pause the video and try 1C on your own. Which side corresponds to angle VXW? VXW is this angle right here, this 37-degree angle. The side that is opposite of that is VW. The next couple of questions talk about angles. The first question says, which angle will be the smallest in triangle PQR? So here's triangle PQR, and we need to remember that the smallest angle corresponds with the shortest side. Now, some of these sides look pretty similar to me, and it might be kind of hard to tell in some triangles, especially which sides are the same or if they're different. We could double check that with a ruler. But in this one, it looks to me like this side right here is the shortest side, RQ. So I need the angle that is across from that, and that's this corner P. But remember, to name this angle, we need to use all 3 points that make up the angle. So we're going to go RPQ. If we're talking about angles, we need to have this little angle symbol to indicate that we're talking about angle, RPQ. Question 1E says which angle will be the largest in triangle MNO. So we need to look over here at MNO, and we have to remember that the largest angle is corresponding with the longest side. In this triangle, MN is the longest side, so we need to look at this angle here and know that that is going to be the largest angle. So that is angle MON. If you also remember from the bottom of our last page where we talked about angle measures, you can only have one right angle or one obtuse angle. If you see a right angle or an obtuse angle in a triangle, just go ahead and know that is the largest one, because if I take the 180 degrees that a triangle is and I subtract 90, that leaves 90 degrees for the other 2 angles. So that last 90 degrees has to be split between both. So I didn't necessarily have to know that this was the longest side. I could have just known, oh, that is 90 degrees, so that has to be the largest. And then over here in this triangle, since that is obtuse, even though these side lengths look pretty similar, I know that that side's going to be the longest side because that is the largest angle. So our last question here says, how can angle MON be classified? And like I was just saying, that is a right angle. And since that's a right angle, that would also be a right triangle. In our next section, we're going to determine the missing angle in the triangles below. We need to remember that triangles have a sum of 180 degrees. So I can take 180 and take away the angles that I know to find the remaining angle. Let's look at question 2. It says to find the measure of angle B when angle A is 32 degrees and angle C is 81 degrees. So like I said, I'm going to take 180 and subtract those 2 angle measures, and I'm going to get that the remaining angle measure is 67 degrees. Let's look at question 3. I've got something similar going on. I know that this is a 90-degree angle based on this little box, and that this is 45 degrees. So I can go ahead and subtract those 2 angle measures from 180. But I also know that if this is 90, that 90 is remaining between these 2, and half of 90 is 45. So the other angle here is also a 45-degree angle. And you would know that for sure if you took 180 minus 90 minus 45. Go ahead and pause the video and try number 4 on your own and press play when you're ready to check. On question 4, I am going to take 180 and subtract 58 and 51 degrees, and I am left with 71 degrees. Question 5 says triangle JHL has angle HLJ, which measures 65 degrees, and angle LJH, which measures 50 degrees. Draw a sketch of the triangle and determine the missing angle measure. So without even drawing the sketch, I could go ahead and figure out the remaining angle measure. And I'll go ahead and do that so that I know if this needs to be an obtuse triangle or an acute triangle, especially since I'm doing this with just as a sketch. So after I take away 65 and 50 from 180, I know that I'm left with a 65-degree angle. So this is going to be an acute triangle. I went ahead and drew just a really rough sketch of this triangle and labeled each corner with H, L, and J. Now, it tells me that angle HLJ is 65 degrees. So I need to find HLJ and label that that one is a 65-degree angle. Next, it tells me that angle LJH, which is right here, is a 50-degree angle, so I can go ahead and label that as well. And then that means that the remaining angle, LHJ, up here, is going to be 65 degrees. In our final section here, we're going to classify the triangles below based on side length and angle measure, and we're going to find the missing angle. So we've got 3 pieces here. So the first thing that we need to do is, on the front of our notes, we're going to determine what kind of triangle it is based on side length. So equilateral, isosceles, or scalene. This one, I see that I have these dashes on each side, and that tells me that the sides are all equal. So this is an equilateral triangle. Since it's an equilateral triangle based on the sides all being the same, that means the angles are also all the same. So I could take 180 degrees and divide it by 3 to find out that each angle is going to be 60 degrees. And since each angle is 60 degrees, that's going to make this an acute triangle. Let's look at number 7. On number 7, none of the sides are indicated to be the same. There's no dashes on any of the sides. So that's going to tell me that this is a scalene triangle since all of the sides are different. Next, I'm going to look at the angles. I've got a 34-degree angle, 118, and x. That 118 is greater than 90, which tells me that's an obtuse angle. So this is going to be an obtuse triangle. Finally, I need to find the missing angle measure. I know that triangles are 180, so I can take away the 118-degree angle and the 34-degree angle to be left with 28 degrees for that last angle. Go ahead and try this last one on your own. You need to label what kind of triangle it is based on the side, the angle, and find the missing angle. Remember to look at the sides and see if any are labeled the same, and then look to see if you have an obtuse or right angle, and that's pretty much going to determine the type of triangle based on angle. If there isn't anything that indicates a right angle or an obtuse angle, then all your angles have to be acute. So looking at this triangle, none of the side lengths are indicated to be the same. So that is a scalene triangle. Looking at the angles, there is this one right angle right here, which tells me that this is a right triangle. Finally, we can determine the missing angle measure by taking 180 and subtracting the 90-degree angle that I know and the 57-degree angle to be left with 33 degrees for our last angle of x. That is the end of today's lesson. If you will, go ahead and summarize today's lesson in 2 to 3 complete sentences. Use correct vocabulary about the new things that we learned. We have learned about triangles, sides, and angles. That's it. If you made it to the end of the video, let me know, do you prefer hamburgers or tacos? Today's lesson was classifying triangles. By the end of this lesson, you should now be able to describe types of triangles based on their side lengths and angle measures. Let me know if you have any questions. Bye, guys.